In this lesson, we are learning how to identify the key features of a linear function from multiple representations. So, linear functions, or lines, can be represented as tables, graphs, or equations. So in this lesson, we're going to learn how to find the key features, or the slope and the y-intercept, from each representation. We're going to start with looking at a table and how to find the slope and the y-intercept from a table. Now, from a table, finding the slope is the same thing as finding the rate of change. In other words, it's just your change in y over your change in x. So we're going to look for the change in y. So from 5 to 7, how did that change occur? That's by adding 2. And from 7 to 9, that's also by adding 2. So the change in y is a constant change of 2. Now the change in x, how does that happen? From 1 to 2, that's going up 1. And from 2 to 3, that's also going up 1. So that's a change, a constant change of 1. So the slope for this linear function represented as a table is 2 over 1, and that simplifies to 2. Then the y-intercept. When you're looking at a table, the y-intercept is always where the x value is 0. So notice we don't have a value of 0 for x in this table, but we know where it would be. It would be right before the 1. So if we had a 0 there, how would the rate of change, or the slope, affect what the value is for the y when x is 0? So remember, this is a constant change of plus 2, and this is a constant change of plus 1. Okay, so from 0 to 1, I added 1. Well, if I'm working backwards, from 1 to 0, I subtracted 1. So from 5 to whatever this number would be, what number would I have to add 2 to give me 5? That would be 3. Okay, so if your 0 is not included in your table, you can use the rate of change, or the slope, to find what the value of y would be when the x value is 0. Now, it's really important to note that this is how you know that it's the y-intercept, is because it's where x is 0. And we'll talk more about that as we look at the graph. For now, we just need to know that when x is 0, that's the y-intercept, whatever that y value is, which is 3. Now let's look at a graph. So in this graph, we want to find the slope. So to find the slope, what you're going to do is find 2 perfect points. So if I zoom in here, I can find any of these points, but I want them to be perfect points. So we have some points up here, but let's look and see what are 2 perfect points. So notice how this point here, it falls between 2 of the coordinates on the grid. So this is 0, 0, this is a point, that's a point, and so on. Notice how this particular point is not a perfect point because it's in between 2 values. It would be like a decimal number. So I don't want to use that point. What I can use is any of these other points that fall directly on the grid. So I could pick any 2 of these. Just to make things easy, I'm going to pick this one and this one. So I'm going to erase these other 2 because I don't necessarily need them. I just need 2 points. Now what I'm going to do is I'm going to count up or down from one point to the other. So I'm looking for my rise over run. So rise means how many did I go up or down. Run means how many did I go left or right. So if I start at this point, then I'm going to count up or down first. So I'm going to go up 2, so I went up 2, and I'm going to go right 1. So my slope, my rise over run, I went up, so that's a positive 2, and I went right, so that's a positive 1. So this slope is 2, or the rise over run is 2 over 1, which simplifies to 2. Now looking for the y-intercept. The y-intercept is just the point where the graph, the line, crosses the y-axis. So remember, you have your x-axis and you have your y-axis. So this red line crosses the y-axis at this point. That just happens to be one of the perfect points that I use for the slope. That's perfectly fine. That's going to happen probably a lot. So now we just have to figure out, where is this point on the y-axis? Well, it's at the point 1, 2, 3. So that value for the y is 3. But as a point, this is the point 0, 3. So the y-intercept is 3, but as a point, we could write it as 0, 3. Now let's look at an equation. From an equation that's in slope-intercept form, which is y equals mx plus b, the slope is the m value, which is 2. And the y-intercept is the b value, which is 3. So I want you to notice the similarities between these three representations. Notice that they all have the same slope and y-intercept. I gave you these on purpose so that you can see how from a table, so from this table here, you can use the slope and the y-intercept to write the equation. And from the graph, so from this line that you were given, you can find the slope and the y-intercept and use that to write an equation. So these three representations, the table, the graph, and the equation, all represent the same linear function of y equals 2x plus 3. All right, let's do another function example in all three representations. So let's look at this table here. All right, we want to find the slope. So remember, that's the change in y over change in x. So the change in y, how are our y values changing each time? So from 10 to 7, that's going down 3, so that's a negative 3. 7 to 4 is down 3, and all of these are down 3. So our change in y is negative 3. Change in x, let's see how the x's are changing. From negative 1 to 0, that's going up 1. And it's going up 1 for each x value. So the x's are changing by 1 each time. All right, so if we were to simplify that, negative 3 over 1 is just equal to negative 3. Now the y-intercept, this time we do have a 0 in the table for an x value. So wherever the x value is 0 in your table, that's where your y-intercept occurs, because that, when x is 0, you're on the y-axis. So 0, 7, or 7 is the y-intercept. Now let's look at the graph of this function. I'm going to zoom in so we can see better. All right, we want to know the slope. So first we need the rise over the run. So that's up or down how many? And left or right how many? Well, we need two perfect points. So I'm going to pick the y-intercept as a perfect point. And when I say perfect point, I want you to be sure that you understand I'm saying it's where the point is on the grid at a perfect intersection. So we're not in between any two lines, right? So the 0, 0, 1, 0, 2, 0, we're not in between them when we pick perfect points. We want to pick perfect points that are on an intersection on the grid. So I'm going to pick another one. Let's say I pick this one down here, and I'm going to count my rise over run. Now, it doesn't matter which one you start with, but just be careful that whenever you start with one, you're counting up or down, and that determines your positive or negative. So if I start with this one, then I'm going to go down so many. So we need to count. How many did I go down? I went down 1, 2, 3, 4, 5, 6. So I went down a total of 6, so that's a negative 6. And I'm going right 1, 2. So that's a positive 2 because I went right. So down 6, right 2. So if I write that slope, negative 6 over 2, I can simplify that. So I don't want to leave a fraction unsimplified. So negative 6 divided by 2 is a whole number, negative 3. All right, now let's find the y-intercept. So the y-intercept, again, that's where the line that's graphed, where does it cross the y-axis? It crosses at that point that I already identified. So what is the y value of this point? All right, now when I am counting, make sure that you're going to get to your y-intercept. You've got to find what is this point. So you need to count from the origin in order to label that point. So this is 0, 1, 2, 3, 4, 5, 6, 7. So the y-intercept is 7 or 0, 7 as a point. And finally, the equation of this function is in the form y equals mx plus b, so we can find the slope in the y-intercept. The slope is always the m, the number that's in front of x. So for this one, that m value is negative 3. And the y-intercept, or the b value, is positive 7. I want to make a note real quick that let's say this was actually a minus 7 right here. I just want to point out that if this were a minus 7, then the b value would be minus 7. But since it's a positive 7, our b is a positive 7. And finally, let's look at this third function in all three forms and find the slope and the y-intercept for it. Let's start with the table again. So we have our change in y first, and then change in x. So change in y from 8 to 7 to 6 to 5, how's that changing? It's going down 1, so that's a negative 1. So the change in y is a negative 1, and the change in x, what's happening to the x values each time? So from 0 to 2 to 4 to 6, they are all increasing by 2, so positive 2. So negative 1 over 2 is just negative 1/2. Now the y-intercept is wherever there's an x value of 0. So when x is 0, y is your y-intercept, so that y value is 8. All right, so our slope is negative 1/2, y-intercept is 8. Let's see if that's true for this table. All right, now we want to find the rise over run. So that's up or down how many, left or right how many, between any two perfect points. Now, there is another way to make sure that you're doing the rise over run correctly by using what you know about how to find rate of change through tables. So, let's say I pick my two perfect points. Let's say I pick this point and this point. It doesn't matter which 2 points you choose, they should all simplify to the simplest fraction possible. So let's find the rise over run first, and then I'll show you another way that you might like better. So first let's say I start here. It doesn't matter which one you start from as long as you are counting up or down, left or right correctly. So if I start here, I've got to go up or down first. So I'm going to have to go up 2. All right, so I rose 2, so that's a positive 2. And then I'm going left, and since I'm going left, that means that number is going to be negative. So how many did I move left? I went left 1, 2, 3, 4 times. So that's a negative 4. So our slope, our rise over run, is positive 2 over negative 4. Well, this simplifies. 2 over 4 can be simplified, so we want to do that. Now, it's always important to understand when you have a negative fraction, you're only going to have one negative symbol, one negative sign. It's either going to go in the top, in the bottom, or out in the very front. So first, let's just simplify these numbers. So 2 over 4 is the same as 1/2, or 1 over 2. So I can write my negative sign in the bottom, or in the top, or out in front. I would highly discourage you from writing it out in front because sometimes it just looks like a really long division symbol and it's hard to tell if you really meant it to be a negative or not. So I would always recommend putting the negative in the top just to be sure that it is a negative fraction. Now, this does not mean negative 1 over negative 2. There's only one minus symbol. So negative 1/2 is our slope. Now, I want to show you, once you have your 2 points, so this first point that I chose is the point 2, 7. And the other point that I chose is the point 6, 5. So what you could do if you wanted to, this is completely optional, it's whatever makes the most sense to you. I could make a table with these 2 points. So the point 2, 7 and the point 6, 5. And from here, I can find my change in y and my change in x. So my change in y from 7 to 5 is negative 2 because I went down 2. So my change in y is negative 2. My change in x is from 2 to 6, which is a positive 4. And if I simplify that, notice that I still get negative 1/2. So if you are not comfortable with counting from one point to another and that is confusing to you, you can pick any 2 perfect points from the line, put them in a table, and do your rate of change from the table. Okay, up next we have the y-intercept. Now the y-intercept on this one is wherever the line crosses the y-axis, which is at this point here. So that's at this point, 0, 8. So it's at 8, or we could label it as a point 0, 8. And finally, we have the equation. Now, up until now, we have had our equation written in y equals mx plus b form. But what if we didn't have it in this form? What if our equation looked like x plus 2y equals 16? Well, what we would have to do is we would have to change this into slope-intercept form. This right here is called standard form. And we don't want standard form. We want slope-intercept form. So we would have to change this to slope-intercept form. So to put this in slope-intercept form, or y equals mx plus b, what we would do is we would solve for y, or get y by itself. That's what slope-intercept form is. So when we are solving for y, remember that's kind of like a literal equation. We have to move the term that's being added first. So we would subtract x on both sides, and that would give us 2y equals negative x plus 16. Notice I wrote it in this order because I want y equals mx plus b. So I want my x to come first. Now I can split the 2 away from the y by dividing by 2. So I'm going to divide by 2, so I've got to do it everywhere. So when I do that, see how this simplifies. So 2 divided by 2 is 1, so that's just y equals. Then we have negative x over 2, and you can rewrite that as negative 1 over 2 x plus, then we have 16 divided by 2 is 8. So now, look how I have slope-intercept form. So now I can see that my y equals mx plus b. So my slope is m, that's negative 1/2. See how when I write the negative in the front like that, it looks kind of like just one long division symbol. So I want to make sure that I put the negative 1 in top. And then the y-intercept, or the b, is 8.